Okay. 3-4 linear programming is what we're doing right now. Okay. Now, I don't know if you've looked at your calendar. Have you? Okay. But if you haven't looked, it says the rest of this week, all we're going to do is 3-4, 3-4, and 3-4. And Friday, does it say TBA? Okay, I have a project and I'm not sure if I'm doing it yet. I got to look at it tonight. We might do a project on Friday on 3-4. So this whole week is what lesson? 3-4. 3-5 doesn't show up till next week. And I think at the end of next week we're talking test out on chapter 3. Okay? So this is a big one. This is a huge lesson that we need to get down. And here is once again your I cans. I can, but here's the deal. Again, this doesn't make sense until you come back later. I'm looking at this right now thinking, I can solve real world problems using linear programming. You're not even doing that today. That's tomorrow. So some of this stuff is all about today and tomorrow, and that's why I say don't read it until the end. Come back and look at it and go, yeah, I can do all 4 of those things. I'm good. I know what I'm doing. Okay, so come back later. Here's where I'm going to start, and the first page, guys, is a lot of reading to you, but it's laying the groundwork, so listen up. All right, it says, some real world problems involve multiple linear relationships. Okay, first of all, multiple linear relationships, that's a system. That just means a linear equation, another one, graph, and we're shading today. So it's inequalities is what it is. Linear programming accounts for all of these linear relationships and gives the solution to a problem. Okay? If I had to give you an example of what linear programming is, it would be something like this. Name a big company. Microsoft. Okay, so Microsoft says, how do we make money? Well, we got to sell computers. We got to sell programs. We got to sell this, that. But not only do we have to sell things, we have to control our costs. How much do we pay our employees and keep them happy? You know, things like that. How much do we work them? 40 hours a week, 50 hours a week? So all that stuff they think about, they write equations and they draw lines and lines and lines and lines and they shade. And when they're all done shading, they have this little shaded region, which you will have, you can see it on the bottom of your notes. It's called the feasible region. The feasible region is where all the solutions are, and their solutions are to make money. They want to make money, so anything in that little shaded region is going to make them money. Now, where in that shaded region do they make the most money? That's your job. You have to figure that out. And that's what you and I are going to do right now. So, you use Microsoft. Last hour, we used Target, Menards. Any big company is using this stuff. Okay, the feasible region contains all the points that satisfies the constraints. The constraints are the limit or restrictions placed on variables. Like if I was selling t-shirts, I might say, I need to sell up to 500 t-shirts. That's the most I can sell. So that's called a restriction on your problem, and you have to graph that. Okay? All right, an objective function. This will be given to you today, but tomorrow you have to come up with this on your own. The objective function is used in linear programming to model some quantity that we wish to maximize or minimize. An objective function may be used to maximize quantities such as profit or the items produced. Okay, so we will maximize profit. That's huge, especially for a business. Minimize quantities such as cost and time. So you want to minimize your cost. You don't want to pay too much money to your employees if you don't have to. The time, how much time should they work at the job, stuff like that. Okay, maximums and minimums for the objective function are found at the vertices of the feasible region. You can probably see it down there on your notes. The vertices are found at the intersection of the constraints. Okay, now all that stuff I just read to you, let me just paraphrase now, okay? You today will get some constraints. What are constraints? Inequalities. Okay, what can x be? X can be bigger than 0 or equal. Y can be bigger than 0 or equal. X plus y will be less than 12, and negative x plus y will be less than 6. These are constraints. So what do you do with constraints? You go what? You go graph them. So here they're graphed. Does anybody know what this line is right here? Straight up and straight down?
X equals 0.
That is x equals 0, yep. How'd you know that, by the way?
Because it's a, I don't know, it's
You just know it?
vertical line on the x-axis.
Okay.
Or the y-axis.
Okay. All right. I was hoping you'd say, because every point on this line has what x value?
0.
Yeah, 0. Look at 0, 0, 0, 0, 2, 0, 4, 0, 6, 0, 8, 0, 10, 0, 12, 0. X is always 0. That's why this is that line. So what's this line right here?
Y.
That would be y equals 0. So when we graph it, it says greater than, which means shade where? Vertical, where do we shade? Greater than 0 to the right. Horizontal, where do we shade? Greater than, above. So once again, I'm kind of telling you shade where. What region do we call this?
The first quadrant.
First quadrant. So we can basically just say quadrant 1. That's what this and this tells you, and almost all of your problems are going to say that. X is greater than 0 or equal, y is greater than 0 or equal, which actually just says what quadrant? 1. That's really all it says. Okay, so now your job is to graph this. Okay, how would you graph it?
Use standard form.
Okay, it's in standard form.
Or graph it in standard? I don't know.
Yeah, but how would you graph it? How would any? Okay, so you're solving for y, you're going to put the slope-intercept form and then graph it. Okay? To me, in these linear programming problems, if I were you guys, I think, Brady, what you meant to say was, since it's in standard, go get your x-intercept, and then go get your y-intercept. That's what I would do, because it's just so easy. If you cover up x, let x be 0. What's y?
12.
12. 0 plus 12 is 12. If you cover up y, 12 plus 0, so there you go. 12, 0, 0, 12. That's right here. 12, 0, 0, 12. Draw your line. Shade above or below. Well, this does say less than. Check 0, 0. Is 0, 0 going to make it less than 12? Yeah, it does. So shade below the line, right? Shade this way. Shade above this one. Shade to the right of this one. And then when it comes to this line, which would be this equation, okay, where do I shade in that one? Anybody know?
Below.
It is below, because obviously it's below here, but if you tried 0, 0, is 0 plus 0 less than 6? Yeah, so you will shade below this line. And see, what happens is this little green region is called the feasible region. If you read up there, that was called the feasible region. And the feasible region has all your what? Solutions, yep. All your solutions fall inside here. Okay, so solutions are all inside here. Now, here's the deal. Linear programming is all about making money for your company. So if all these points make money, which one makes the most money? Well, you think it's the very top one, right here? Well, here's the deal. Where you make the most money is only going to happen at the vertices. I think it said it up here somewhere. It's probably higher up. Maximums or minimums for the objective function are found where? At your vertices. So where are your vertices? Right here, where the 2 lines intersect, where 2 lines intersect, 2 lines intersect, 2 lines intersect. So you have to pick out your 4 vertices and stick them in those blanks right there. So can you tell me any of the vertices?
0,
0,
0.
0. Okay. What? Give me another one. 0, 6. Yes. Give me another one.
12, 0.
12, 0. Give me another one. Oh, it's right here. It's right there. Are you having a hard time?
Yeah.
Trying to figure it out? Guess what? It's where two lines intersect. So, do we have any methods that can help us determine where these two lines intersected? Is there a method you know of that I could do to solve where these two lines intersected? Well, first of all, what line is this? That line right there happens to be negative x plus y equals 6. This line right here happens to be x plus y equals 12. How are you going to know where that line and that line intersect? Do what method? Yeah, the elimination. Negative x, positive x. Elimination on this one. Okay, can we just do this in our head? What would this and this be right here? Nothing. What would 1y plus 1y be? 2y equals 6 plus 12, 18. Y is 9. So these two lines intersect at something comma 9. Now that you know it's 9, what plus 9 equals 12? 3. So basically, the intersection point was supposed to be at 3, comma 9. Okay? And I don't think it looks like 3, 9, does it, on your paper? No, see, and that's, I think I purposely made it not look like 3, 9, because I didn't want you to know what it was. But here's the deal. If you think your graph is that good, if you really think it's that good, and you know it's 3, 9, all you got to do to know if you're right is what? Plug it in. Is 3 plus 9, 12? Yes. Is negative 3 plus 9, 6? Yeah, it is. So it works. You didn't even have to do this method. I wanted you to do the method just to see that it works, okay? Okay, now, here we go. This is what you're doing. You're looking at your feasible region. You want to pick out which points maximizes your profit. So find the maximum and minimum profit with the vertices. So my vertices were 0, 0, 0, 6, 12, 0, and was it 3, 9?
Yes.
3, 9. Okay. Okay, with those vertices, you're supposed to plug it in the profit formula. The profit formula was given up. Oh, there it is. It's right here. It's right there. It's 2 times x plus 3 times y. So what kind of profit do you make if you produce 0 computers and 0 software? How much money are you going to make?
0.
Probably nothing. So put it in 2 times 0 plus 3 times 0. You made 0. Nothing. What you probably found was your minimum right there. But we're also looking for the max. So what if I produce this? 0 computers and 6 software items, I guess. 2 times what? 0. 3 times 6. What'd you make?
36.
18? $18. Okay. 12, 0? 12, 0. 2 times 12 plus 3 times nothing gives you 4. 3, 9. 2 times 3. 3 times 9. What's that? 24?
33. Oh, wait.
That's 27 right here.
My bad.
Yeah, plus 6, right? So that's 33. Okay. So you did all that work. Picked out the vertices, put it in the profit formula, and really all you did that for was one reason. Find your maximum and minimum. So what's your max?
33.
Maximum is what?
33.
$33. Maximum equals $33 at what? At what point? Got 3.9. Now tomorrow when we do these problems, you're going to say this. You're going to maximize your profit if you produce 3, whatever we're talking about. Maybe if we're talking farming, if you produce 3 combines and 9 tractors, you will maximize your profit. So tomorrow it's more story-like. Today it's just number crunching. What's the minimum? Okay, $0. You make nothing. At what point? At 0. Okay. So even though that feasible region had all the answers, some of the answers are not really good answers. You are probably going to make money. You'll make money inside here, but you're not going to make much money. Where do you make the most money? Right about. Wasn't that the answer? Yeah. This is the point you would, as a company, you would say, let's do this. Let's make 3 of these and 9 of these. If I make 12 and nothing, 12 and 0, I make money, but I don't make the most. Okay? Did that make sense? Is this what you've been doing? Graph, shade, shade. The only thing that's really new to you is pick out the vertices and stick it where? In the what formula? Profit formula. That's really all that's new to you. Okay? All right, we get to the next problem. I didn't graph it for you. So this is going to get harder for you because you got to start graphing on your own. So here are your constraints. Can you do it? Can I give you a minute head start? I'm hoping in a minute you have the first 2, maybe the third one done. Okay? You're doing exactly the same thing, trying to maximize your profit. Think of it as x equals 0, y equals 0, which is exactly what we get here. This one, right? Then I did that one, I said 2, that's where you're at right now. Well, if I were you, this is in standard form. Okay, I would come over here with 0 for x. 0 for y. And then give it, I cannot find this, I cannot find this. If you let x be 0, that's common. And it says 2y equals 5. That's the answer. Okay, so 0 is 2y is 1. Then let this one be this one. And always the same. X equals 5. 5, 0, and 0 to 5. Right? All right. Which one's vertical? I'm just curious if you know. Is it the x equal or is it the y equal? X. This one's the vertical line, in case you didn't know. This one's vertical. Okay, this one's horizontal. And since they say 0, again, it says greater than, we're talking first quadrant only. Okay, so here is y equals 0. And we're shading above. This is x equals 0. We're shading greater than. So that would be to the right. We're in the first quadrant. This one, I'd go get my x-intercepts, y-intercepts. Okay. Haley, did you get the y-intercept?
2.5.
2.5. Okay, I agree. How about the x-intercept?
4.
4. I think you're doing this one.
Oh.
If I cover up the y term, x plus gone, 5 plus what? Well, I said that wrong. I meant to say what plus 0 equals 5. Doesn't that have to be a 5? Right, guys? Hey, when you do x, y intercepts, do you guys in your mind just do this? Just pretend it says equal, right? Don't look at the less than sign or the greater than sign. Don't do that. Just think of it as this plus this equals 5. Then solve it. So I get 5, 0 and 0, 2.5. Okay, what about this one here? What are the x and y intercepts? Louder if you know. 4 and 4, yeah. 0, 4? 4, 0. Okay? Are you good? Now, before you start graphing, would you just listen to this? Because I know some of you already started graphing. You do not want your lines to do this. Here's a line. Here's a line. Oh, here's the feasible region right here. You know, that's... What's wrong with that graph? It's so tiny. And you know why that happened? Because you guys crunched all your numbers in the corner. What I would like you to do is spread your graph out. Just go, don't just go by ones all the time. Since your numbers are so tiny, your numbers are 4, 4, 5, 2.5, you guys spread it out. What do you want me to count by? Yeah, I would too. I'd say every 2 squares is just 1, 2, 3, 4, 5. That way I have spread out the graph a little bit. 1, 2, 3, 4, 5. Well, I'll put a 6 up there just for now. Okay? Alright, now if I graph this one, 0, 4, 4, 0, it'd be here. It'd be here. I would connect it, right? And by the way, I might just do this. X, I want to tell myself that's x plus y equals 4. Okay, what about shading that line? Let's put in 0. Let's put in 0. 0, 0. Is 0 plus 0 greater than 4? No, so shade where? The other side, right? So we go this way. Shade, shade, shade. Oh, so all the answers are out there and above and to the right. Do you guys see your answers? They're all out here. Yeah. Except there's another line. What's the other line look like? Well, right here. 5, 0, right here. And 0, 2.5. That would be right here. Connect. Right there. Okay, question. Do I shade above blue or below blue? Below? Put a 0 in, put a 0 in. Is 0 plus 0 less than 5? Yeah? 0 plus 0 is less than 5. Okay, so yes it is, yes. So shade where? Below, below. Hey, everything I've done so far doesn't even matter. Because the answers are out here. The answers are all out here. Until you get here, right about here, now it's starting to matter. Where have I shaded 4 times?
Right now,
It's the little tiny triangle right here. We call this the feasible region. This is where all the answers fall. Oh, next up, once you know the feasible region, go get your vertices. 2 of them are easy. 0, 0 is not a vertex.
0, 4.
0, 4.
4, 0.
Okay, 4, 0, yes.
And 0.
And what?
5, 0.
5, 0. Okay. 4, 0, 5, 0, that'd be this point. This point. What's this point?
3, 1.
You think it's 3, 1?
Yeah.
How confident are you?
Very confident.
How do you know?
Because I did the elimination method.
You did the elimination method. Oh, that's different. I didn't know you did that. She did it, so I trust her, but you know what? If you're just reading your graph, be very careful. Let's just quick do it in our head. Is this true? Okay, ready? Is 3 plus, you said 1, right?
Yeah.
Is 3 plus 1 4? Yeah. Is 3 plus 2 times 1 5? Yeah. She's got it right, but Haley did not tell me or you. She didn't tell you. She did the elimination method. She took this line, x plus y equals 4, and then she said, where does that line intersect this line, which is x plus 2y equals 5. You know what you guys should do? You guys should do this on your paper so you know which equation goes with which line. Okay? Haley, what did you do to solve it?
Multiply the top equation by -1.
Okay, multiplies the top by -1, gets negative x, negative y, and -4, draws her line, x's disappear, y equals 1, right? If y equals 1, go right here, guys. What are the easy equation? What plus 1 equals 4? 3. X equals 3. Okay, so there it is, 3, 1. 3, 1. Hey, where's the other vertex? There, yeah, I made a mistake when I wrote the notes. There's only 3. There's only 3 vertices. Okay, let's go maximize your profit or minimize your profit and see where it's at. So what are they? 4, 0, 5, 0, and 3, 1. Profit formula. Just take 2 times x plus y. 2 times x plus nothing. 2 times 5 plus nothing. 2 times 3 plus 1. What's our answers? 8, 10, 7. Once you throw your vertices in, you see your maximum profit. It only happens at the vertices. So we have to say in this problem, our maximum is $10. At what point?
3,
5, 0.
At 5, 0. At 5, 0, you guys will maximize your profit. And then your minimum profit, you will make the least amount of money, $7. At what point? 3, 1. Good? Hey, is there much new here? Haven't we been doing this? Haven't we been graphing lines, shading? Right? It's just that now there's just so much more coming at you. Okay? And tomorrow it's a story problem. So tomorrow you gotta read it, get all that information out of it, write the constraints, and then start all over. Okay? Alright, last one. Now, hang on. I hope you guys didn't start this problem. I don't like the 35. Would you please just change it to 40? There's a reason I changed it. I just don't want to go into it why I did that, because it has to do with the graph. The graph didn't look the greatest, and you couldn't tell the vertices, so I made sure I changed it to 40. This is kind of a difficult problem. I'll give you a 1-minute head start. Just try to graph some of that. Oh, by the way, I wouldn't graph until you know your XY intercepts, because you want to know the biggest X and the biggest Y you're going to graph. Okay, which line is vertical? X equals 1 or Y equals 6? X equals 1 is vertical. Okay. Y equals 6. Horizontal. Okay, don't forget that. Anybody have XY intercepts for X plus 5Y? Yeah, I'm all, what is it?
0, 4,
0, 4,
20, 0,
and say what?
20, 0.
20, 0. Okay. Yep, I agree. 20, 0, 0, 4 are the XY intercepts. Okay, bottom equation, 4x plus 5y. Jimmy, do you have it?
Not that one.
Not that one? Hunter, do you have it? No?
8 and 10.
Which one's 8?
The top.
Okay, 0, 8?
Yeah.
0, 8? 10, 0? Is everybody okay? Do you get why I'm getting these numbers? All we're doing is letting this y be 0, cover up the y term. 4x equals 40, divide by 4, 10. Cover up the x term. Divide by 5, 8. I mean, that's really all you're doing. It's just a quick division problem. Okay. Well, guys, your biggest number you're going to graph on the x-axis is what? 20. Your biggest number on the y-axis is 8. So on the x-axis, can we make it to 20?
Yeah.
By ones? Well, for sure we can do it by twos. Can we make it by ones? Because I want to stretch this graph out.
Yeah.
Yeah? Okay. So there's 5. There's 10. I think that's 15 right there. 16, 17, 18, 19, 20. Just made it. Okay, now the biggest y value is 8. If you stretch your graph out, you're not going to go by ones. Because if you go by ones, 8's right here. And that means your graph is done right here. We want to get up as high as we can. Can we do something else? Go by what? If I go by 2's, it's even quicker. Well, 2, 4, 6, 8, I'm done. That's way too quick. Halves. Go by halves. There you go. Every 2 squares is 1. That's what I would have done, just to stretch it up. There's 4, there's 5, there's 6, there's 7, there's 8. That's what we want. We want it up. The more stretched out it is, the easier it is to read. Okay. 0, 8, 10, 0. 0, 8, 10, 0. There it is. Okay. If I try 0, 0, does 0, 0 work? 0 goes in, 0 goes in. Is 0 plus 0 less than 40?
Yeah.
Yep. Okay, so we're going to shade this way. Okay. Oh, I forgot to do my vertical line. My vertical line was x equals 1. So that's straight up. X equals 1. And now right or left?
Right.
It said greater than. So it's all right. It's out. Everything to the right. Hey, is there any reason for me to keep going? Look. Why would I keep going? Because everything's supposed to be under the blue, right? Okay. All right. The horizontal line, y equals 6, right here. Okay. Where do I shade?
Down, vertical.
It says less than 6. Less than. Down. Everything down here is the, oh no it isn't. Not until I get inside here. So really it's down below this green. Under this. To the right of this. You guys, you see the area? It's right here. This is the answers. Except there's another line. What's the other line? I can't even read it. What is it?
0, 4.
0, 4. Okay, what else?
And then,
20, 0. Okay, 20, 0 is way out here. Draw the line. There it is. Shade above or below. Let's put 0, 0 in. Let's just see. 0 plus 0 is greater than 20. No, it's not. Don't shade this side of the red. Shade what side? The other side. There's no reason for me to keep going because it's to the right. There's no reason for me to keep going because it's under the blue. See it? That is where you find all your answers. Okay? Pick out the vertices. And by the way, there's only one vertice that's really nice. Which one's really nice? One that you can visually pick it out. Because a vertical line and a horizontal line are going to be exactly what x is and y is. 1, 6 is right. So this one's done. We got this one. Okay. Should we go get this one right here? What is this point? Well, this point is this line. This line is y equals 6. And this line, what's this line? That would be 4x plus 5y equals 40. Okay? Do you get what I'm doing? This line is y equals 6. This line is 4x plus 5y equals 40. How do we solve that?
Substitution.
Yeah, this one's... Oh, what do I have x's for? I got 2 x's. Sorry. 5y. Okay, so drop the 6 where? In for y. 4x plus what? 30. Take away 30. 10. X equals what?
2.5.
Y equals what? 6. Okay, we've got another one. 2.5, comma 6. 1, 6. That wasn't too bad, was it? Okay, what about this one? Right here. Right there. What do we know about this line right here? Going this way. That's the other one. That's
X plus 5y is greater than or equal to 20.
just say equals for now. Equals what?
Plus
20? What's this line right here?
Y equals
That's y. No, it isn't. X equals 1. So x equals 1 meets up with x plus 5y equals 20. Which method? Substitution. Put the 1 in for x. Oops, I should have just put 1 in. 1 plus 5y equals 20. 5y equals what? 19. Divide by 5-ish. 3.8. Yeah, see, they get kind of nasty. Okay, so when x is 1, y is 3.8. Now, the two diagonal lines. This diagonal meets up with this diagonal. Well, now you got to take this right here and match it up with this one up here. Right? So now this is the one where I would probably try your elimination here. X plus 5y equals 20 meets up with, what's the other one? 4x plus what? 5y. Okay, so those two meet up. Where do they intersect? Which method? Elimination? Well, you could do substitution. You can solve for x. I personally, I see 5y, 5y. I just get this 5y to be negative. Negative x, negative 5y, negative 20. Draw your line. Add now.
3x
3x equals 20. X equals what? Divide by 3. 20 divided by 3. 6 point, ooh. It's 6 repeating, isn't it? 6 repeating is 6 and 2/3. Okay? Now, where would you put the 6 and 2/3? In for one of the x's. How about that one right there? So 6 and 2/3 plus 5y equals 20. 5y equals, how do you get the 6 and 2/3 over? Subtract it. 13 1/3 is what we came up with last hour. Now what? Divide by 5. The answer? Where do they intersect? 6 and 2/3, comma. That's not what we got last hour. We got 2. We got 2 and 2/3. Try that again. Try that again. You're doing it in your calculator, aren't you?
Yeah.
Yeah, do it again. I think it's 2 and 2/3. 6 and 2/3, comma, 2 and 2/3. There it is. These are your vertices. These are the 4 possible maximums or minimums. Did you get it, Anthony?
No, I must be doing something wrong.
Oh, I'll come and look. Here's your profit function right here. First profit, here we go. At 1/6, 8 times 1 plus 2 times 6 equals. What's it equal? 8 plus 12 makes 20. I don't think that's your max. Okay, one more time. Here we go. 2.5, comma, 6. This time I'm just going to ask you for the answer.
Alex, flip into the office, please. Alex, flip into the office.
I remember the answers if you will just say them. You have to punch these in. 30 what? I'm on the 2.56 one. That one's 32? I do remember 32 being in there. How about the 1 comma 3.8? Guys, I can do this faster in my head than you guys are. Come on. 1 times 8 is 8. 3.2 times 2. 3.8 times 2 is 7.6. 15.6, right? 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 Is that what you got? Okay. Last one, 6 and 2/3 times 8. And 2 and 2/3 times 2. It is 58 and 2/3. That's 66 cents. I think last hour they got 12 cents. I'm not sure how they got 12 cents. Okay. What's the, well, that's right here, 58. Okay. And by the way, I knew that was the maximum, that's why I put it there. The minimum was $15.60. At what point? Gotta tell me where it happens. 6 and 2/3. 2 and 2/3. Where did minimum happen? 1 comma 3.8. Yeah, you have a book assignment. If I were you, I'd take 2 of these. The nice thing is, the bottom left corner is your origin. Okay? Take 2. The book assignment, it's all the same stuff, what we just got done doing. Camille said tonight,
My book was open.
Jaden, you all right? We made it!